All right, since I'm going to go ahead and work out problems from this worksheet, I'm actually do the whole worksheet. You've got a different version of a same exact idea, just different numbers, or at least some are different. Most of them are different numbers. All right, so we are in number one. You notice this is little a is 8, little b is 6. Well, if I know my Pythagorean triples, I know it's a 6, 8, 10 Pythagorean triple, which is a double of the 3, 4, 5. Now, if you haven't chosen to remember those, then you have to go ahead and use Pythagorean theorem and go a squared plus b squared equals c squared to solve for your c. Okay, so now that you know that, it wants me to find the sign of a. Remember, I have to know where big A is. It's always across from little a. So there's a. Big B across from little b, and big C across from little c. Okay, you got to know that. We talked about it in class many a times already. Okay. Oops, what did happen there? Okay, so the sign of A. So here's where theta is right now. Sine, remember, SohCahToa. So sine is opposite of hypotenuse. This is my O, and there's my H. So 8 over 10. And I reduce 8 over 10 down to 4/5. If you don't reduce, you lose a half point. Each one's worth a point. Cosine of B now. Okay, so now I'm doing theta is up there at B. So now this is the opposite, and that's adjacent. Remember, I told you if theta moves, then the O and A move. H never moves. So the cosine we see is A over H. Adjacent, 8 over 10. So it's the exact same answer, 4/5. Then we have the tangent of A. So now theta goes back over here to the A again. And now that would be the adjacent, and that's the opposite. Opposite and adjacent. And what's tangent? Remember, tangent, as it shows up here, is opposite over adjacent, 8 over 6. And that reduces down to 4/3. Cosecant, oops, of B. This is 6 then. Okay, cosecant of B. So theta is a B. Cosecant is 1 over sine, so it's a reciprocal of sine. Since sine is opposite over hypotenuse, cosecant would be hypotenuse over opposite. So the hypotenuse, 10 over the opposite, 6, 10/6, or 5/3. The secant of A. Okay, so if theta is at A now, then this is the adjacent, and this is the opposite. Secant is reciprocal of cosine. Cosine is adjacent over hypotenuse, so reciprocal will be hypotenuse over adjacent. So 10 over 6. Again, simplifies to 5/3. And lastly, cotangent of B. So now theta is up here again at B. This now is the opposite down here, and this is the adjacent. Remember, hypotenuse never changes. So cotangent is the reciprocal of tangent. Tangent, as we see up here, is opposite over adjacent, so the reciprocal would be adjacent over opposite. So that's going to be 8 over 6, which reduces to 4/3. And there's all your 6 trig functions of SohCahToa. All right, number 2. Same idea, except for not a Pythagorean triple. Little a, okay, you can pause the video if you haven't written all this down. I'm going to erase it. Okay, so I can write in everything in here. We'll change the color to green this time. Okay, little a is 8. Little c is 14, so I have to use Pythagorean theorem to solve for b. So I have 14 squared minus 8 squared equals b squared. So it's 196 minus 64 equals b squared. What's 196 minus 64? Will be 132. So b would be the square root of 132. Square root of 132. Which then simplifies down to what? Well, 12 times 11 is 132 if you know your times tables. Square root of 11 doesn't break down, but square root of 12 does into 2 root 3. So now that is going to equal 2 root 33. So that simplifies down to 2 root 33. Okay, we need to simplify that because we have to reduce our radicals or fractions afterwards anyway. Again, I'll change the colors for A, B, and C. Let's go A, B, and C. Remember, all capital letters for angles. All right, so sine of B. Theta at B. Our hypotenuse never changes. So in this case, this is the O and this is the A. Sine is opposite over hypotenuse. So 2 root 33 over the hypotenuse of 14. Well, 2 over 14 reduces to 1/7. So root 33 over 7. My answer. Cosine of A. Move that there. And so now this is going to switch. This is now my A and this is my O over there. Okay, so the cosine is adjacent to root 33 over hypotenuse 14. So it's the exact same answer. Root 33 over 7. Okay, tangent of B. So now we move theta up to B, which now means these two switch. And don't forget, tangent is opposite over adjacent. We'll write SohCahToa again over here. Tangent, so that's the first thing you should write on your paper when you have your test, SohCahToa. Make sure you spell it correctly. You gotta have it memorized. Okay, so tangent is opposite over adjacent. So now we have 2 root 33 over 8. That's going to simplify to root 33 over 4. Okay, so now go ahead and pause the video, write that down if you need to, because I'm going to hit clear screen so I can now do the last 3 and not be having to scrunch things in there. Okay, so again, A there, B there, C there. Okay, 8 was A, 2 root 33 was B, and C is 14. Okay, that hasn't changed. All right, cosecant of A. Remember, that's the reciprocal of sine. Sine, let's put SohCahToa up here again. So cosecant is reciprocal of sine. Sine is opposite over hypotenuse. So reciprocal is hypotenuse over opposite. 14 over 2 root 33. Okay, well, that counts down to 7 over root 33. But remember, no radicals in the denominator, so I must rationalize it. Always multiply by the same thing. So I get 7 root 33 all over 33. And 7 over 33 doesn't simplify. So there's my answer. Okay, secant of B. So theta's at B, which means then this is my opposite and this is my adjacent. Secant is the reciprocal of cosine. Cosine is A over H, so secant is H over A. Okay, H 14 over A 8. Following one without a radical. So just divide by 2 and I get 7/4. That's a secant of B. Got the theta there. Okay, cotangent of A. Moving the whole thing over here now, which means O switches over to here and A switches back to here. Okay, hypotenuse never changes. Cotangent of A, remember that's the reciprocal of tangent. Tangent is over A, so the reciprocal would be A over O. So 2 root 33 over 8. And that 2 and 8 cancel down. Simplify, I mean. So root 33 over 4. That'd be my answer. All right, so we got that. Go ahead and pause the video if you need to. Write that down. And then play it again. So I'm going to clear this off. Make more room here. What do you notice about the sine of A and the cosine of B? We talked about this in class. Remember, these angles have to be complementary. So if I was to put this in here, A, B, C, and it says sine is 65. Let's say this one's 65, then this one has to be 25. Remember, they have to be complementary, add to 90. So in this case, the sine of 65 would be B over C, opposite over hypotenuse. Okay, well, that equals what? I need in terms of cosine of what gives me B over C? I need to equal B over C again. Well, that'd be the cosine of A, which is 25 degrees. The cosine of 25 is B over C. Okay? So just know that. Oh, yeah, so we have two separate problems here. That's what a semicolon. Cosine of 27 would equal the sine of 63, right? 27 plus 63 is 90. Of course, you see the word in parentheses, complements, complementary. Add to 90. That's a DCAS question. You'll see that on the DCAS. That's why I put it on here. It's different numbers. They might even on the DCAS say X. Well, then that answer is cosine of 90 minus X. Okay, because remember, X plus 90 minus X adds to 90. Remember, they have to be complementary. So just know that. All right, you draw yourself a triangle. You walk 2 miles south, boom, directly south, then 6 miles west. 2 miles, 6 miles. It says, how far are you from your starting point? So that's just Pythagorean theorem. It's 36 plus 4 is 40, square root of 40, therefore. Miles, that's the exact answer. Let's just round your answer to the nearest hundredth. So now you put square root of 40 on your calculator. So remember, I've sent you the link of this before. Go to graphing calculator. That's the test nav site. Hit start. Go down, hit start again. Oops, I thought I did. Hit start again. The calculator's right here in the middle. Right there. Open that up. Clear it. You can move it to the side if you wanted to. Shrink that. Shrink that. Oh, that's already up. Can I get that? Can I get that to show right there? Guess not. All right. So what was it we were looking for again? Square root of 40. So second square root 40. Oops, I have to move this calculator up. 40, enter, is 6.32. We're going to the nearest hundredth spot. 6.32, therefore. 6.32 miles. Okay, how far are you from the starting point? Let's say how many miles, so you have to actually add in that unit so you lose a point. Don't forget that. All right, number 5, right triangle with right angle C. So we can use this right here. Has lengths A equals 4 and C equals 14. Find the exact value of B. So this is just doing Pythagorean theorem. So I have 14 squared minus 4 squared equals B squared. 196 minus 16 equals B squared. That's 180 equals B squared. And we know we could do 16 times, no. Well, I can do 20 times 9. Okay, that's 180. That's 3. Root 20 breaks down to 2 root 5. So 2 times 3 is 6 root 5 is my exact answer. Okay, 6 root 5. Pythagorean theorem. All right, let's go ahead. If you need to pause it, and then move it back on. All right, if angle A is theta, identify on the drawing your OA and H. So angle A, so you have to know where angle A is across the little a. That is theta. Hypotenuse remains the same. Opposite is across from. Adjacent means next to. There you go. You're just naming that. You did a whole page of that on the worksheet on the first trig day. Okay? So you can see you're going to have one of those again. Because again, if you don't know OA and H, you're going to blow this whole test. And this assignment here. Angle A is 20. Remember, I know it's angle A because it's capital letter. Lowercase b, which is side length b, is 9. Find A and C to the nearest tenth. So again, the hypotenuse, the opposite, and the adjacent. So I'm going to go for A first. That'd be O over A, which is tangent of 20. Remember, next to its trig function is a degree. Opposite is A, little a, over adjacent, 9. Just cross multiply, I get A equals 9 tangent 20. Put that in a calculator. Now, don't forget, I have to change the mode to degrees. Second quit. Right next to it moves it back. I can clear that off. Okay. And what was the problem I was doing again? 9 tangent 20. 9 tangent 20. 3.3. If we're going to the nearest tenth. We're going to the nearest tenth? Yes. So A is approximately 3.3. No units given, so I don't have to worry about that. Now C is approximately what? Oh, I'm writing it down here. It actually should be up here in this problem. Okay. So C, we have, again, we're using A over H. A over H is cosine, so cosine of 20 equals A, which is 9 over C. That's a 9, not an A. Cross multiply, I get 9 equals C times cosine of 20. Well, I have to get rid of cosine of 20, so I divide by cosine 20 on each side. And now put it in my calculator, and we're around to the nearest 10, so it's an approximate. 9 divided by cosine 20. 9 divided by cosine 20. 9.6 is my answer for C. Okay, now, remember 9.6, that's the hypotenuse. That better be the longest side. 9.6 is longer than 9, and it's longer than 3.3 that we got for A right here. Okay, so it does make sense. It better be greater than 9 because the hypotenuse is got to be the longest side. All right, go ahead and pause the video if you need to get any notes off of that or rewind it. All right, 8, same thing again. So you just practice that same thing again. So over here they tell me angle B is 22 and little b is 4. Okay, so I need to find A and C again. So 22 is my theta, so there's my opposite, there's my hypotenuse, and there's my adjacent. So I'm going to go for A first, A to B. I have to use the 4, so I have opposite and adjacent. So it's tangent of 22 equals the opposite, 4 over the adjacent, little a. Now, I'm going to go ahead and show you a different way. I talked about this in class. If that's 22 degrees, we know these are complementary. That means this has to be 68 degrees right there to add to 90. Now, the reason I'm bringing it up, because if I use this tangent of 22, notice when I cross multiply, I'm going to eventually have to do 2 steps. I'm going to divide by tangent of 22 afterwards. Do 4 divided by tangent of 22. Okay. Now, if I chose to use the 68 degree instead, which then makes this the adjacent and this the opposite, if I'm using 68 degrees, I can do I'm using 4, which one I solve? I'm solving for A. Okay, so I can use tangent of 68 equals the opposite, which is little a, over 4, the adjacent. Now when I cross multiply, I get A right away. A equals 4 tangent 68, and I don't have to do 2 steps. Now I just plug in a calculator, and that's 4 tangent 68. 4 tangent 68. 9.9, there's 10th. Okay, now remember, I'm not going to use that 9.9 because that's a rounded answer. If I would have solved this one, I had 4 divided by tangent 22. Just check 4 divided by tangent 22. Look at that, 9.9, exact same answer. Okay, now I need to solve for C. Okay, so again, I can use either one. It's 22 or 68 degrees, but I do have to use this 4 here. So if you use 68, again, I'd have adjacent over hypotenuse, which is cosine. So cosine of 68 equals the adjacent over the hypotenuse, C. Cross multiply, C times cosine 68 equals 4. And last step, divide by cosine 68, and then plug in a calculator. So that's approximately 4 divided by cosine 68. 4 divided by cosine 68. 10.7, around the nearest 10th. And again, that makes sense. C has to be the longest side. crossing the right angle, so 10.7 makes sense. All right, go ahead and pause the video if you need to. Write all this down because I'm going to clear it. Okay. Number 9. Last couple here. If little e, remember that means the length of a side is 11, and little d, which is the hypotenuse in case is 19, find angle F. You guys see it's angle F because it's a capital letter. So I want you to find that theta right there. It's the nearest hundredth. So this is the adjacent side, and that's the hypotenuse. That's cosine. So cosine of theta equals the adjacent, 11 over 19. Remember, I have to get rid of cosine now, and that is done by inverse cosine. And whatever you do to one side, you must do to the other side. So now I put inverse cosine of 11/19. Inverse cosine is second cosine. Parentheses right there, 11 divided by 19. You get 54.6. Because I wanted around nearest hundredth, 54.62. So theta is approximately 54.62. Make sure you read the directions. It's around to nearest whatever they want. Here's another one. The practice one just like it. Little f is 5, little d 22, and big E, which means that's the angle we're solving for, is nearest hundredth. So again, this is the adjacent over the hypotenuse. So I have cosine of theta equals the adjacent 5 over the hypotenuse 22. Again, I multiply both sides by inverse cosine of 5/22. Plug in my calculator, inverse cosine of 5/22. Inverse cosine of 5 divided by 22. Enter 76.86. 76.86 degrees. Okay, in degrees. All right, we got through all 10 problems. So you were able to practice everything. Finding the angles here. We practiced finding side lengths on 7 and 8. We identified your HO and A. Okay. We did Pythagorean theorem twice. Once rounding it to the 100 spot, once finding the exact answer in 4 and 5. We did our complements theorem right here in number 3. And we did all 6 trig functions in 1 and 2. So that covers everything geometry-wise that you need to know a trig all on this sheet. So this is a great review sheet of doing everything all within 10 problems. All right, that'll end it. 23 minutes.